Hello everyone and welcome to my very first video. I'm Michael Butros, a professional data analyst, and here I'll be telling stories through data. So let's dive into our first chapter of 1000 Stories with Data. In our first chapter, we will be investigating the Gapminder World Dataset. Together, we will explore three key indicators across 186 countries, which are population, life expectancy, and income per person. This dataset spans from the year 1800 to 2050, giving us a fascinating look at how the world has changed and where it might be heading. Throughout this analysis, we will answer some big questions, such as has the average population across countries increased over the past 100 years? Is the population expected to keep increasing in the coming years? Has the average income per person grown over the past century? And will it continue to rise in the future? Has the life expectancy improved over the last 100 years? And is it expected to keep improving in the years ahead? And finally, what is the relationship between income, population, and life expectancy? By the end of this chapter, we will uncover how these indicators are interconnected and what they reveal about the global progress.
First, we need to import our libraries. So to be able to read our CSV files and manipulate them, we need to change our CSV files to data frames using pandas library, and we will use matplotlib library also to be able to visualize our insights. Second, let's open our CSV files and change them to data frames. I have already uploaded them to my local Jupyter server. Let's start our data wrangling. First, we need to know the total rows and columns for each data frame using the shape function. As you see here, the live data frame and the income data frame have 195 rows, but the population data frame has 197 rows. Additionally, the live data frame and the population data frame have 302 columns, whereas the income data frame has 252 columns. Therefore, we need to remove the excess columns and rows to ensure all data frames are equal. Now, we will take a look at the head of each data frame to explore more data. So some letters in the population data frame and the income data frame has letters that represent a value, which are K equals 1000, M equals 1 million, and B equals 1 billion. Now we will check if the three data frames have the same data types. So we don't have the same column types, and to fix this problem, we need to change every letter to its value. Now let's check if the data frames have any non-values. So we also found that the life expectancy data frame has a total of 9 non-values that need either to be filled or removed. Finally, let's see if the data frames have any duplications. There is no duplication in the three data frames. Second phase, our data cleaning. So as we have seen above, we don't have the same rows, columns, and data types, and we also have non-values, so all these need to be fixed. First, removing all access columns. Since our income data frame has the fewest columns with 252 columns, we will use it as a reference data frame and make a function that removes the excess columns from the live data frame and the population data frame based on that data frame, and this function is called column equalizer. Once this function is called, the for loop will search all the columns in our targeted data frame, which is represented by the y attribute, and if these columns aren't in our reference data frame, which is represented by the x attribute, the columns will be removed. Now we'll make sure that we have the same number of columns. And now we have the same columns. Second, as you have seen above, the population data frame has 2 more rows than the other data frames, so we need to remove all the access rows. So we need to make a loop to find and make a new list where the access country rows will be added in it. Here, we choose the live data frame as a reference data frame, but you can use the income data frame as well if you want, since they both have the same rows. After knowing the 2 countries that we need to remove, we will filter the population data frame with these countries and remove them. After removing the 2 countries rows, making sure that we have the same country names. Third, removing non-cells from the live data frame, but before removing them, we need to know the country names that have these non-values to remove them also from income data frame and population data frame as well. And instead of using the same code twice, we'll make a function that filters the targeted data frame that is represented by the X attribute with the countries we want to remove, and this function is called country equalizer. Now, to remove our non-values from a live data frame, making sure that we don't have any non-values, making sure that we have the same country names in all data frames. Fourth, to fix data types for each income data frame and population data frame, we will make a for loop that searches for each element in our columns and splits the letters that represent its value, and it changes the number to the desired value, which are K equals 1000, M equals 1 million, B equals 1 billion using lambda functions. Now we need to make sure that all data frames have the same column types. Here, the income data frame has only 2 types: object for first column, which are countries, and flow for other columns. Let's see our live data frame. The same thing in our live data frame, and finally our population data frame. We also have the same thing in our population data frame. Now, all data frames have the same column types, so now we will enter our third and final phase, which is our exploratory data analysis to answer our research questions. Our first research question is: has the average population of all countries increased over the past 100 years? So, to answer our first research question, we need to filter our data frame to the last 100 years of the current year and then get the average population of all 186 countries each year. So, let's start our visualization. This is what our population was from the past 100 years. So, as you see here, the average total population of all 186 countries has increased from less than 1 billion people in the year 1800 to 4.5 billion people approximately in the year 2025. Now, let's start our second research question, which is: is it expected that the population will increase in the following years? So we will use the same filtering method to visualize our insights. As you see in our visualization, the average total population of all 186 countries expected to increase to more than 5 billion people by the year 2050. Let's answer our third research question, which is: has the average income per person of all countries increased over the past 100 years? Since the income data frame has the same columns as the population data frame, we don't need to make the column filtration again. We will use the population filtering. So let's start our visualization. So as you see here, our average income per person of all 186 countries has increased from less than 2,500 in the year 1800 to more than 20,000 in the year 2025. So let's start our fourth research question. And our fourth research question is it expected that income per person will increase in the following years? We also use the same filtration method. Also, as you see here, our average income per person of all 186 countries expected to increase to more than 37,000 by the year 2050. Our fifth research question is, has the average life expectancy of all countries increased by years in the past 100 years? Also, since the life expectancy data frame has the same columns as population data frame, we don't need to make column filtration again. So we'll use the same filtration method as we used earlier. As you see in our visualization, the average life expectancy of all 186 countries has increased from less than 40 years in the year 1800 to approximately 78 years in the year 2025. Now we will start our sixth research question, which is it expected that life expectancy will increase in the following years? I can't say it no more. We will use the same filtration method. Also, in our visualization, the average life expectancy of all 186 countries expected to increase to approximately 80 years by the year 2050. Our seventh research question is, what is the relationship between the income indicator and the population and life expectancy indicators? First, we need to get the average income per person and the average population and the average life expectancy of all 186 countries each year. So there is a positive relationship between income per person and total population, which means that when a person earns more money, their ability to make a family increases, which finally increases the population. So let's see our relationship between income per person and life expectancy. Also, there is a positive relationship between income per person and life expectancy, which means that when a person has more money, his ability to take care of himself increases, which in turn increases his life expectancy, which finally increases our population. Of course, there is a limitation in our project, which is some countries didn't have any non-values, so I had to remove them from income data frames and population data frame, which may affect the result and produce inaccurate statistics.
And that's it, everyone. We have just wrapped up our first chapter and our very first story with data. I hope you enjoyed it as much as I did. Don't forget to subscribe and hit that notification bell so you won't miss the next chapter. More stories with data are on the way. You can find the GitHub link in the description box to access all the datasets and the complete code. And if you prefer reading, I have published the full breakdown of this project, including all the steps and findings on Medium. You will find the link in the description as well. Bye bye.